So good morning, everyone, and welcome to our meeting for the 17th of May, 2024 for the AgRobotics Working Group. We have two new members. I know one is on the call right now. We have Angel Sanchez from Fanshawe College. Angel, if you just want to give a quick introduction on who you are and what you do at the college as well.
Yeah, good morning, everyone. Thank you for inviting me to this meeting. My name is Angel Sanchez. I'm the manager for the two research centers here at Fanshawe. One is called the Center for Connected Building Technologies, and probably is the one that is probably of most interest for this group. We have some printed circuit board capabilities, and also we have access to the supercomputer hosted at University of Waterloo for huge calculation and data management, machine learning, validation, testing, and design. So yeah, the interest of Fanshawe to be involved in this group is the huge potential for automation and artificial intelligence in agri-food. So I'm happy to connect later with anyone that might want to know more about Fanshawe College and how we can support your research projects. And very happy to be here. Thank you very much.
Thank you for coming. And we also have Sandra Ludwig from the National Research Council. If you want to give a quick
hi
introduction.
everyone. Thank you for having me. So I'm an industrial technology advisor with IRA based in Guelph, supporting agri-food companies across Canada. And my interest in joining this group is I actually recognize a lot of the names in this group. It's one of the jobs that we have is really understanding what the ecosystem is offering, and so that we can advise our companies on opportunities that might be available to them. So I knew some of my companies are part of this and some of the people in the ecosystem. So I wanted to join in and hopefully be able to contribute to this group as well. Thank you.
Thank you for being here.
And I can confirm that Sandra has a really good Rolodex of connections.
Yeah.
Well, that's good. That's another great connection for the AgRobotics Working Group. And I think that's all the new members. Is there anyone on the call that I haven't introduced that's maybe has snuck on, just in case? I know there's the odd person that nips on every once in a while. No?
Has David Bilson introduced himself to the group yet?
Don't believe so, actually.
Yeah, I'm just with the RHA Ventures, one of the coordinators working with the Grow. We invest in agri-food startups in southwestern Ontario and beyond. Our new fund is actually looking at going pan-Canada. So we're in the process of raising a $20 to $30 million fund to invest in agri-food startups. My colleague Nevin's on the call as well, our managing partner. So if you ever hear of startups that are looking to make an impact in agri-food, that are looking for investment, please send them our way.
Nevin, I don't know if you wanted to introduce yourself as well. If not, no, I'll take that as a no. Welcome to the call as well. And then for today, for our presentation, we have Triton Innovation. So Colette Tackett, if I'm pronouncing that correctly. We introduced her last call as well. So she'll be our presenter today, and she'll be giving an overview of the organization and what's going on there.
Yeah, and it's take us to the ball game.
Perfect, thank you.
How's everyone doing today? So what I'm going to share my screen. Hopefully everybody will be able to see it. And we're going to talk a little bit about let's see. But what we're doing with our very cool robotic automated it's out in the field right now, so it's a robotic autonomous asparagus picker at this point. So we're going to go through. I'm going to kind of I'm waiting for Steve to jump on. I'm not sure if he's attended already.
I'm here.
Oh, you're here. Hi, Steve. How you doing?
Hi, everyone.
So I'm just going to do a quick introduction to myself. My name's Colette Tackett. I've been with Triton since 2020. And before that, so I've got 35 years of IT shop floor OT experience. And then I jumped in with Steve at Triton, and we've done all kinds of wonderful things in the development of robotics and industrial automation. So that's me. Steve, do you want to introduce yourself?
Sure. I started in automation right from a young age, so directly out of college. I worked in automation for about 6 years. Then I took a bit of a break and went into automotive vehicle production level stuff, which I really didn't like. So then I started up Triton in 2013 and got back to what I like, which is building cool, fun stuff. Lots of automation, lots of agricultural related equipment, some automotive stuff, some general industry stuff, kind of all over the place. So, yeah.
There you go. All right, so introductions. So we'll do Triton. At the core, we're industrial robotics and automation, established in 2013, and we're hardcore at that. So we've been into hundreds of companies doing robotics, so that's our base. Harvest Corp, of course, Harvest Corp's all about farming. So background was tobacco farming, got into other farming, and became mechanical design. He also had, he's unable, his name's Rick Derrick, I'm sorry. And he hasn't been able to join us today. He's actually in the middle of moving. So he was unable to join us. Anyway, he's a mechanical design guy. He's very hands-on, came to Triton and talked about his idea, and we are developing it together. So since 2020, we've been in development of this autonomous harvesting unit. It's pretty cool. So let's talk a little bit about what we're doing here, our vital issues. At the heart of this solution is all about the manual labor issue, the foreign worker issue. We know what that's all about. The manual cost of labor, housing, remuneration, insurance. So when we look at our robotics, it really does aim to alleviate those challenges and potentially save our farmers millions if we can do it. Right? So what's the goal? So develop this fully robotic autonomous vegetable harvester. Now we're looking at asparagus. Right now we're out in the field. Now we're going to do broccoli and cauliflower. That's the direction we're going. So we have a very visionary approach. We're looking beyond the traditional methods. And there are the folks right there. They're manually harvesting asparagus. Now that looks like a really awful job. They have a big knife and they're out there and it's dirty. And, you know, if we just can get a robot to do it much more sustainably, terrific. We want to increase efficiencies and productivity as well, and not having to hurt yourself with a big knife. That's always important. So here's our journey. We want to explore the details of our robotic agriculture. Why and where are we on this journey? And we want to envision the future where technology meets this traditional farming. So why are we on this journey? Well, it's not easy, I'll tell you that much. So we've got cutting edge vision and sensor technology that, of course, Steve and his team have put together. And it was a learning curve because we've been in industrial robotics for certain, you know, working in shops all over the place, but we haven't looked for asparagus in a field. So that's been an interesting challenge. We've got machine learning algorithms working with us. We've got tons of AI. We've been working with different solutions there and coming up with some wonderful direction. We've got speed comparisons with humans. Currently, we're one-to-one with humans. We're trying to, of course, improve that speed. Our focus is on precision and robot as a service. Now, does anybody out there understand what robot as a service is? Because currently what we're thinking is robot as a service. So farmers out there can almost like lease the robot and to, you know, get their toe wet with it and see, okay, is this something that we really want and give it a try. Why not? So robot as a service is something that we're actually considering. And if you you want more information on that, please give us a call. We're happy to kind of go through that with you. Or you can talk to Chuck as well, and I'm sure he'll be able to help. So, and we're also looking for technology maturation. So the reason we're where we are right now and where we want to be in the next 5 years is going to be completely different. We're looking for more ideas. We're looking at how do we get it to the next level. So all of this is very exciting. So where we are on this journey continues. We're looking at precision monitoring, predictive analytics, all those things right now that are not easy to do for the farmer. We're looking at data coming in. We want to have that data because currently the data you get the next year, we want that real-time data to make those decisions that are really important for the farmer. We want to look at resource optimization. Right now, we have to have so many people out there assisting with, with the cutting of the product and the, tagging and toting and all that kind of thing. We only want to bring it down to 2 people, and that would be a little bit less expensive, that's for sure. The robot and a couple of people, we're good to go. That's the direction. So envision the future farm. All right, now let's put our thinking caps on. So can you imagine? I know this is kind of space age, but we're looking at the next 5 years as a full collaboration between agriculture and robots, and it can happen. So farmers and robots working side by side, contributing with their unique strengths, because we have hands and our robot doesn't. So that's always something. Farms where data and smart sensors and robotic systems provide real-time data insights. It's extremely important. And we see this in the automotive and the industrial world, where all the data is coming in and you can make those decisions, those smart decisions that farmers don't have access to currently. So this is a direction we really want to go, and we're hoping that farmers see this as the next step. So farming even more committed to sustainability. So robotic solutions guided by AI, of course, contributing to environmentally conscious farming practices. And we all know that farmers want to have environmentally sustainable practices, but how do we integrate it? How do we make it better? And I think by going with robotics, it would be a terrific solution for that. And we also see a future where collaboration between agriculture and robotics results in, of course, increased productivity, profitability, and speed. So here's the call to action. We look forward to let's create that cultivation of for tomorrow's farms, integrated, efficient, sustainable. We want to make the future farms more of a global community. Let's get that data in there, make things more resilient for a brighter future. And, together we can sow the seeds of progress. Sorry, I had to say it. All right. And yeah, we're happy to take any questions. Steve and I are here. Any questions for us today?
One thing I should mention, Colette, is we've now since revised it that we should be back to, or we should be down to 1 person to run this machine. So per machine, it's only one person, not 2.
Super.
Hi, Colette. I have a couple of questions here. The first one is, do you have, when you are trying to pick up the asparagus, do you have too many false positive or whatever it's called, like the machine is trying to pick up where there's nothing? And the other one is how are you training the machine learning algorithms to understand where, to reduce this false positive in case you have any?
So that's interesting. I'll take this one. We actually have built in a independent learning module for the machine. So each farmer will be able to, let's call it tweak the model for their system. So we've trained it right now. I think we have the base vision model has 1,000 images annotated that it knows from positive, negative. The farmer then has the option that they can go back and review. I can't remember how many we're saving right now, but they can go back and review, and just with a checkbox or an X say, yes, this was asparagus, this was. And if there was any negatives, they can say, nope, this was not, this was not. And then it feeds back into that model and helps tune it, because every field's going to have a little bit different condition. Even from year to year, you're potentially going to see different different conditions. Maybe a different weed might look like asparagus, right? So it might take a few times of going through and, you know, tweaking that out. So far in our testing, though, we haven't had too many false positives. Right now, we're trying to tune it for height because we get very, we're picking a lot of asparagus, but we still have to tweak the height sensor a little bit. That's what's the current status for us right now. But otherwise, it's not too bad.
Super.
And what are you using to identify the asparagus? Like a conventional camera or any other technology in addition?
Yeah, so it's a stereoscopic camera. So we get actually a point cloud with a depth map that we can analyze.
Okay.
And so it's that integration of how we're using the image recognition software and then tying those points to the point cloud where we can extrapolate the height. So that's the piece right now that needs a little bit of tweaking, because we can identify the asparagus, we go to the location, but we're not quite there on the exact height dimensions, right? So we've been picking stuff that's a little bit too short and leaving stuff that's kind of optimal height. So that's, you know, hopefully I think Monday we'll be back in the field to get that tweaked out. So
your system is creating like a 3D match of the product, right?
kind of. So we're using the vision model for the identification, and then from there you pulling out at those specific XY coordinates, we're pulling out the height for that. So
okay.
Probably not like a full, most of the 3D matching systems require a CAD match to go forward with. If you're doing any kind of vision recognition, it matches to CAD, which you
like
could
a
probably
scanner,
do it. Yeah, which, you know, we're not going to get a CAD model of asparagus that's going to fit all the time.
Yeah.
So, you know, we kind of went down that road, and then we thought this way is probably better, where we're getting the coordinates from the stereoscopic camera and then extrapolating the height from that point cloud. So,
okay, thank you.
Thank you very much for the question. Chuck, I see you've got your hand up.
Yeah, I had a couple of points, and one was I saw that there's a comment in the chat about the cost savings for the grower.
Mm-hmm.
And my point is kind of related to that. There was a LinkedIn post last night talking about how one of the large asparagus growers in the UK, I think it's called Norfolk Farms, is exiting the asparagus industry due to the lack of labor. So sometimes it's not just about the cost of the labor, and it's whether or not you can actually get it.
yeah.
And the other piece that I picked up from your presentation, Colette, and it was echoed by I was on a joint call with Area XO and a large farmer, vegetable producer from the Ottawa area on Monday or on Tuesday, and they have 18 workers doing their vegetable work, and the issue that they have is that the foreign workers that they're bringing in are refusing to do the hand weeding. They're refusing to do the harvesting, the bending over, the whatever. They don't want to do it. And not only that, the quality of the harvesting that they're doing declines as the day goes on.
Mm-hmm.
So I think this is what's interesting on your data piece. When we talk about robots as a service, and we talk about robotic systems, and we talk about labor, the robot should theoretically be able to harvest at the same level of quality all day long. Where,
Yeah,
you know,
that's
and
right.
that's one of the things that's hard to measure. So I think in our calculations going forward, that is one of the things that we need to start looking at. It's not good enough to compare a robot against a person for a 45-minute test. You know, it actually needs to be at different stages over the day. And otherwise, we'll have a case of, John Henry against the steam machine, right? We don't, people will, if they know that they're being measured, they're obviously going to try and do a better job, but it has to be kind of a hands-off type test.
Right. No, thanks, Chuck. Kristen, it looks like you have your hand up.
Hi, Colette. Yeah, I was
Hi.
just curious if you had a video handy, like to see underneath the tarped area, to see it working, that you can share, or
Do you have one on your computer, Colette?
No, I've got too many things up on my computer right now to see.
Yeah, I was just curious because
You
it's
may
always
have
very unique to see underneath how the blades are working, and then once it's to get for the group to get an understanding, like once it's actually cut, how it goes into a container and that kind of thing.
If you want to at a later point, you can send it to me and I can get that out to the group as well. If you don't
Or
have
if
it
you
on.
have it on your website, you got
Mhm.
it somewhere. Yeah,
I
I
think,
was
I
just
think
curious.
Steve's looking for one, right? Do you have one, Steve?
Yeah, I'm gonna check it out. We can answer other questions in the meantime. I think I should be able to screen share.
There's
So
one question in the comments as well. From the harvesting data, will you be able to generate a yield map for the field, either in pounds per acre or spears per acre?
yes. So the really cool part about that is because we're using an RTK GPS system, in theory, now we've kind of roughed in a bunch of it, but in theory, we know not only what we've picked today and at what location in the field down to the inch, but we also will know the stuff we left in the field. So, the stuff that was high enough to pick, that stuff we would know exactly what we picked, but then we'll also know for future, because a lot of times in the perfect growing conditions, you can be in the same field twice, right? Because the stuff that's only 3 or 4 inches will be ready to harvest later that day. So we can actually give a predictive model like Colette was talking about before, where we can say, hey, you know what, you might want to plan that you need to go back in the field again later this afternoon because you've got a bunch of stuff we left that's all at 3 inches. And even maybe concentrated to this area. Like we know this area of the field has a bunch of stuff that's imminently close to being harvested. So then the farmer can make a decision based on that, whether he can go back through. So not only a current yield map, but even a predictive yield map of, over the next 12 hours where you might need to be.
Any other
Thanks,
questions?
Steve.
Sorry, Kristen, I hope I didn't cut you off there if you had another one. We have another question in the chat as well. How close are you to commercialization? If close, what is the anticipated cost?
So we are close. The machine we have developed now is a single row unit. We are kind of, we're kind of deciding between a 2 and a 4 row. There's a better usage of capital if we can go to 4 row, but there's some thoughts from some farmers we've talked to and Chuck and some of the other people that a 2 row might actually be better. So the cost per row, let's say, of the machine will be higher, right? Because things like the generator and the robots and, there's a base capital cost there, which we could leverage up to 4 robots. So a 4 robot system right now, we haven't really ran the new numbers because prices have went up quite a bit since the last time we did this. But it's looking like it's going to be in the $300,000 to $400,000 range for the sales price. And then, like Colette mentioned, we've been looking pretty hard at robot as a service, knowing that being new, a lot of people may not want to just drop that kind of money out of the gate, right? So if we have 1 or 2 that we can deliver to your field, you pay X amount per week or month or per kilogram. We haven't kind of settled on the model for that, but that's certainly an option as well.
It is. And we've got another question from David Hobson.
Hi, interesting presentation. Love it. Can you tell me a little bit about your operating parameters? Can it operate at night? How long can it go without a charge? I'm assuming it's all battery powered. What's your kind of life cycle? Are these machines you're thinking you're gonna build them to last a year, 5 years, 10 years? Certainly, as you were just saying, capital cost is a big issue because a lot of people are gonna want to harvest in the same week.
Yeah.
So it's like, how do you get that machine to everybody, or does everybody have to buy a machine just for 1 week? And so that's a hard business, nut to crack. But mainly I'm interested in kind of your operational parameters, I'm assuming you could pick at night, right? So can you just talk a little bit about that?
Sure. The interesting thing with this is, because it's vision, we try and keep the light as controlled as possible. So that's why we have the tarps, we have bright lights underneath. And absolutely, if you have a guy, part of our business model, the cost per kilogram produced of asparagus goes way down if you can run this, 2 guys running 2 12-hour shifts, right? I mean, that runs all through the field all night long, no issues. It's actually not currently battery powered. We have a small inverter type generator. So really there's no limit other than fuel, and it doesn't use very much. There is a plan in the future, obviously, to go battery and solar would make a lot of sense. But right now I don't think that the generator is a limiting factor there. And then in terms of reliability, because of our industrial background, it's kind of why we think this is a better fit than some of the other solutions that are out there. Is industrial robots are built for a minimum 5-year service life. And on top of that, normally you're going to get 10, 12, 15, maybe even 20 years out of that same system. Usually you're going to want to replace it before it wears out, just because there's so much better stuff out there, right? So it's not usually that it wears out. It's usually that you can get more speed or some other new option by upgrading the equipment. So, we think that's kind of a nice advantage that we have too. We have that experience of building industrial grade stuff that's meant to last. This isn't, 2 guys in a garage building with Meccano. We kind of have that figured out. So, yeah.
Yeah, it'll run in the rain as well, David, which is kind of great. So, we 24 hours a day, and we don't have to worry too much about the weather. Any other questions for us today?
Hi, Steve. It's Joe Dales here.
Hi, Joe.
Steve, you also have some stuff for the hatching industry, the egg industry. Do you want to talk a little bit about some of your product lines there, just to inform the group that this is one product, but you have other ones that you do for the agri-food sector?
Yeah. So we actually just got awarded a contract for a machine, again, a little, not prototype for us, but prototype for their system. They've been working with the Egg Farmers of Ontario, and they're now able to detect the sex of a chick prior to incubation. So at day 0, which is kind of a huge game changer for that industry. So we're working with them and building a machine for them to help sort those eggs. So once they scan them through, they'll be able to tell which ones will turn into males, which ones will turn into females. We're separating those out. And then, the ones, if males are desired, males are more desired for the meat industry, and females obviously for the laying industry, right? So if you're hatching laying hens, you want all the females. The males can go to table eggs, right? They'll sell them at a grocery store, where now they hatch. If you're looking for laying hens, they hatch. 49% of those eggs turn out to be male, and they just get euthanized. There's no commercial use for them. So it's a pretty big game changer in the industry in terms of that. And then we've built a bunch of egg transfer machines, just transferring from hatchery trays into incubator trays. I think we've built 5 machines now for that.
That's right.
Yeah, and then a couple that actually we kind of pull the trays out, put a basket on, and flip them directly in the process. So we're able to eliminate I think 3 independent machines and combine it into one cell with an industrial robot. So it works out pretty well.
Yeah, and it's so interesting to see an industrial robot in a barn. That's very cool. So we got another question here, Carl.
Yeah. So my background's a little bit in the service sector for ag equipment. And the question I have with the robotics is, they start to go into commercialization. What's the service support plan once these hit commercialization? Are you going to have a tag onto a dealership network that's going to be a servicing arm for you, or what's your plan there?
Yep, you nailed it 100%. So we're going to have a dealer network of guys that are well trained up and well versed in specifically advanced robotics, and you know, so they'll obviously have support from us being local. We're in Ontario, right? So if we have to send one of our techs out, we can. But the benefit for that is it lets our techs who are developing the vision software and all that good stuff stay focused on the vision software, right? And the next generation, the next iteration, and then we have the field techs from the dealer that will be out in the field, you know, dealing with the day-to-day issues of you know, production and all that fun stuff.
Great. Any other questions for us today? Oh, Steve.
Or see a video.
Ah, there you go.
Able to yeah, so this is a little bit this was our first testing, I think, in the field this year. So it's with a shaky iPhone camera. So don't judge us on our filming expertise, but I'll play here. Is the video moving? It doesn't look like it's moving on my screen.
No, I don't see anything. No, not viewing it, Steve.
Yeah, I don't know what happened.
I think
Well,
while Steve's figuring that out, and this is for it's Angel from Fanshawe. Like the role, I think, for colleges and for other schools is developing this pool of technicians and people that can help support these machines, and especially as we're moving, you know, industrial robots outside of the factory and out into the field and stuff like that. There's going to be a role and a place for training and education and support, repairs, development, software. Like there's a whole, you know, industry starting up, and which is exciting to see.
Yeah, you're totally right. One of the main goals of us as a college and is our student. They are our core business, and is what we want through this research project, right? That they have the train, they are out with an industrial partner, and they are able to learn something new, something cutting edge technology, and hopefully then the companies are able to hire them for, you know, for future opportunities. So yeah, you are totally right.
Maybe just one more question. You did talk about going into other vegetable crops like broccoli and cauliflower. We know
Yes.
that there's a couple of places that have been kind of dabbling. There's a couple of companies, one in the US and one in Quebec that has a broccoli harvester. I just wondered where you are in terms of that, like that vision and new technology.
Sure. So I guess they were out in the field last fall with broccoli, and it went pretty darn good, and they will be out in the field again this fall. So what they have to do is change the end of arm tool so that tooling works for the broccoli. There also has to be a blower system because we have to get rid of all the leaves, so they have to be blown and then before we can cut. So there were some things both with the cauliflower and the broccoli that were that are completely different than the asparagus. So we were able to do that. And what was really exciting was just the amount of broccoli we were able to bring in just with our first test. So this is really the next wave of things that we want to be able to do.
Well, I was going to add, Colette, that so we were asked, like Haggerty was asked by a company out of California about to follow up with anybody who's doing some work on cauliflower harvesting. So we'll definitely, I think we've talked about this before. And then one of the challenges that we need to resolve, and this is for people on this group that are looking at imagery and image analysis, is how to figure out how to find the cauliflower when it's enclosed to harvest it. You know, like, and so that's going to be a challenge, and I'm sure that Harvest Tech would love to have some help to try to sort that out.
Yeah, we certainly would. Now, Steve just told me that his Zoom crashed, so he's jumping back on. I'm not sure.
We'll take one more
and
question. Oh, sorry,
Yeah,
go
and
ahead.
just so people on the call know who might not know about cauliflower, all the workers have to go through the whole field and tie off the cauliflower so as it's maturing, it doesn't get sun scalded or any other marks on it. And so that is a whole nother part of the equation. How do you find a robot to tie off all the cauliflower before you harvest it? Because it's a huge job, right? So,
We're gonna take one more question and then we'll move through the rest of the agenda and then we can get to the round table. And then if there is any more questions, we can have them addressed there. David, if you wanted to give your last question. Oh, you're muted.
Pressure. Actually, two quick questions. First one is, what's the holy grail that you want to harvest? So right now you're working asparagus. That seems like the low hanging fruit, you know, a stick sticking straight up.
Right.
You know, what 10 years from now, what's the holy grail that you want to try and harvest? And then the second question is, can you tell us a little bit about, did any programs or government help you, or are they helping you? Like, tell the other people here, hey, we tapped into IRAP or NSERC or whatever else because we got to use that free money.
Well, you know, great questions. The first question, our holy grail would be to not have to worry about people out in the field at all. We want to be able to harvest it all and make it easy. And, you know, looking at like cauliflower is very difficult. But asparagus, because it grows all over the place, I mean, this is not easy. So, you know, taking that and going, all right, what's next? We want to be able to help the farmer diagnose his field and make it easy to harvest. So that's, you know, regardless of the product. The other question is IRAP. IRAP helped big time. We've been working with Ron for the last few years, Ron Evans, and he has been not only instrumental, but helpful and patient and just terrific to work with. So IRAP was really there. And then of course, Joe and his team were great as well. Oh, looks like, oh, we've got video. I feel like this is like on the moon when we first went to the moon.
It gives you the idea of what's happening.
Yeah, yeah.
So is there a blade on the bottom of that robotic arm that's doing the cutting?
There is. You see how he grabs it? A big comb.
So everyone eat more asparagus, okay?
Yeah, yeah. It is delicious. See, and they don't grow particularly straight up off the crown. They're kind of everywhere.
Do you have any plans for white asparagus? Because that'd be a whole nother ball game as well.
Yeah, I'm sure they do. I'm not sure what that plan is, though. I don't think we grow a lot of white asparagus in Ontario, though. So, never know. That's great. So what we'll do is we'll send this video over to you guys and you can send it out to whoever would like to view it.
Absolutely.
Super.
Thank you
Thank
very
you,
much
Steve.
for that presentation, Steve and Colette.
Thanks.
It was very informative. And if anyone would like to get connected with them, if you don't already have their contact information, we're more than willing to connect you with them.
Thank you.
So we'll just go through some of our other items and then we'll get down to the working group. So if there is more questions, I feel there might be in this group for them, we can continue that on. But conferences, meetings, and field tours. So number 3 on the agenda, there was the AgRobotics Aviation and Robotics Summit, sorry, on the 14th to 16th of May in Pittsburgh, Pennsylvania. Did anyone attend that? I haven't heard of anyone attending that. So another one that didn't make it into the agenda, but I'm going to actually put a link in the chat right now. There is a new program out from OCI called the Critical Industrial Technologies Initiative. So I just put a link in the chat there. They're going to have a webinar on the 22nd of May, which I do believe is just next week. It's either Monday or Tuesday. Nope, it's Wednesday at 10 a.m. So if you want to find out more about the program, there's a webinar there to go through all that. That link that I sent out also has information on it. They are looking to hit on 4 key sectors: mining, advanced manufacturing, and agri-food and construction. And then one of the critical technology areas is actually robotics. So there could be a really great connection there with this program and some of the projects that are going on as well. So just wanted to get that out to everyone. There is also an event on the AgRobotics website if you don't get that link by any chance, so you can find it through that or just reach out to us as well.
And just to add to that, the OCI is specifically trying to address labor shortages in agri-food. So it's exactly where you want to be.
Fantastic. Thank you for that addition. The other item that's coming up is the LRIC Annual Symposium, which is on the 20th of June, and that's the Greenway Event Center in Elora. One of their keynote speakers is going to be Mary Wells, who's the Dean of Engineering at Waterloo. And they're looking, the whole presentation is engineering a better farm. So I'm assuming that's going to have quite a bit of either robotics, sensors, or anything along those lines kind of worked into that. So that might be a note of interest. Save the dates. This has changed a wee bit from our last meeting. We're looking at possibly doing the 10th of July for the one meeting. We're still confirming on the actual location for our demo days. The other one, though, will be being held on the 4th of July at the Muck Station. So that one is pretty well set on when and where. More details will be coming out with that. We have our planning subcommittee, which I'll talk on a wee bit later, kind of helping us with that. The International Symposium on Robotics and Automation will be happening on the 22nd of July in Manhattan, Kansas. And then we also have the AgRobotics Application Conference on the 31st of July, which is a virtual conference as well. And a quick update on the project and what's going on. So we just had our first meeting with our first subcommittee, which is the planning subcommittee, just earlier this week, and we kind of went through different items on planning all these demo days, and then what we're also going to be doing for demo days in the future or other events kind of surrounding that. So more information will be coming out on these, and we're also planning to have more subcommittees established soon. One would be data. If anyone does have any other ideas for subcommittees or something that would be beneficial, we don't want to be oversaturated here, but we're more than willing to hear things that would be beneficial to the community we have here as well. There's a couple, I don't think we've added anything new on the funding announcements just recently, other than the one event with that webinar that'll be coming up. So I will switch it over to the round table now so that if there is any more questions, we can have them fielded. Yes,
I just wanted to let everyone know we will be out doing a demo in a field, either in the Simcoe, likely in the Simcoe area, within the next few weeks. And Aaron, I'll let you know when that is, so and where it's going to be, and see if we can get some folks out to have a look and view our very cool technology.
That'd be fantastic. I know there'd be a lot of interest here in that. So.
Super. We're looking forward to it.
Any other questions for Colette or anything else to be brought up for the group? So we're at the roundtable section now. Joe Dales?
I think Chuck and I had a call with Jacqueline and Emily this week, and they're interested in anyone that's got robotics in Manitoba that they want to, if they want to demo it or showcase it out of their farm. north of Winnipeg. So if anybody needs an introduction to Jacqueline, we're happy to do that.
Fantastic.
I think I had a call. I've been having a couple of calls with Area XO about coordinating some demonstration and other work efforts in the Ottawa area with them. One of the project farms actually is it's going to be with pumpkins, and it happens to be right. The farmer actually rents some of the land that Area XO is on, so it's actually pretty convenient, and they have access to a technician as well as land and the farmer and the crop. So all that kind of aligned, and it all kind of happened by accident. You know, one person talks to one person, and anyways, it works out. Just building on Joe's point with Emily out of Manitoba, they want to continue some work with weed imagery and weed scouting, and so I will, let the group know kind of what that means. Essentially, they want to make sure they're doing the same stuff that we're doing. Using the same cameras, taking the same kind of images, labeling them the same way. So I will keep the members of the group informed as to what's happening. And then I think the other piece would be, I don't know whether Grant, you want to just talk about the, kind of what's been going on with the robots for the last week. I know you were gone almost every day. So just for Hagerty AgRobotics, we hired 4 summer students, summer technicians. They all started last week, and they're getting trained up and going through. But Grant, you want to give a chat update as to what's been happening?
Sure. Yeah, just been busy the last week, trying to get everything squeezed in between rainfall events. Had some rain at the beginning of the week and then the end of the week today. So yeah, busy getting robots going. This week we were focused on the TED robot up at Cave Spring Vineyard. Basically just testing out its navigation, making sure all the paths that it is following are as accurate as possible. The idea with it is to start cultivating in the next week or two, so we want to make sure the navigation is as accurate as possible leading into that, so we're not messing around with that side of things when we need to be cultivating. So that was our priority this week. Also getting another couple more Oz shipped out and delivered to customers, and making sure those are all running good. So and then yeah, that was kind of majority of the week this week. So
and then you guys tried out some modifications to the farm droid up at the research station as well.
Yes, yeah, we tried out some teeth that we had developed to replace the weeding wires on the farm droid. Just a little bit more aggressive to hopefully take care of the weeds a little better in that area. And then some row guards as well to hopefully stop some of the soil from being thrown on the small emerging onions when they're very young. So tried out our initial prototype on the farm droid on Tuesday, I believe that was. And it was a very, very muddy day, and I had to take the truck through the car wash after because it was caked in mud. So got some pointers on how to make version 2.0 of those modifications. So we'll hopefully have those built next week to try out, and hopefully get those fitted on when it's ready to start cultivating. So
fantastic. Thank you for those updates. Izmir has her hand up.
Yes, hi everybody. Colette, I just wanted to tell you that I'm working for the vegetable growers in Quebec, and that includes asparagus growers, and they already told me that they want to see machines like yours in demo. So I just wanted to know that I am here for the times when the times comes to see your machine. And in others, I just want to share that we are organizing a demo with the ARA precision sprayer, and it's going to be around June 15th. So I will send you the link for the invitation.
Thank you.
Thanks.
Any other items or questions or comments? Well, thank you, everyone. Oh, Dan?
Oh, sure. Yeah, I'll just mention down in Michigan, we've got a new farm droid in operation down at Michigan State, and similar to Grant, playing with the navigation system to make sure that's working all right. And we've started planting some things and just getting our feet wet with that technology. We'll be doing a couple field days at some of our Western Michigan sites later in the summer involved with that. And then we also have an Oz that we're continuing to work with at the station down here. So kind of focusing on the weed management side of robotics. Just thought I'd mention those things.
Fantastic. Will you be having any demo days or anything like that?
Yeah, we're in Western Michigan. I think it's August 16th. We're going to demo it, the farm droid, to some of our veg growers. I can give more details if anybody wants to head that way. And then probably going to bring it down to the Midwest Mechanical Weed Control Field Day, which is at Purdue in September. Contingent on sorting out what we're doing with it. So we'll keep you posted.
Appreciate that.
Yeah.
What crops, Dan, are you trying out right now?
We're starting with cole crops on sandy soils. So we planted some cabbage, and we'll do a small amount of onions. We have muck growers similar to what Grant is working with, but holding off on doing much with them at this point, focusing on sandy soil crops, so cole crops, some root crops like turnips and rutabaga, kind of bunch planted, to see how that works. So that's kind of our initial, and probably some red beets. But all we have in the ground now is cabbage. We're starting off with that.
Yeah, so we had some pretty good luck with rutabaga with the farm droid in the past on sand, and actually it was brought up to us that cabbage would be a great fit for that robot. We kind of think it'll be a really good use case, especially we got to make some modifications to tooling, but we think it'd be a good fit for that machine.
Yeah, I agree. And there's some growers with interest in those crops who do relatively large scale organic, so it might be a good fit. Except for the problem of center pivot tire tracks. Some things to work out. But.
Mary Ruth, see.
Yeah, Aaron, a little bit more of an update on the farm droid in the Holland Marsh. Did see the 7-acre site at Keswick. There were a few hiccups. Kevin explained that to Grant when he was up, and also seeded another 3 acres for that same grower. And we have a small trial with seating arrangement at the muck station, and that all got done. I just wanted to mention 2 years ago, I was in Washington State and saw a broccoli harvester in action. I think they trimmed the leaves first, and then they went through with the harvester, but they were harvesting like 8 or 12 rows at a time. And after it got finished in Washington State, they were going to move it to California to do more harvesting there. I have some notes somewhere right now. I can't remember the name of the company, but it was based in Washington State, and it was all, the initial reason was the problems they were having finding enough labor to do this.
Thank you for that update. Colette, did you have anything anything to add on to that, or I just saw you
Well, that,
unmuted.
yeah, just if she does remember who the company is, that would be great. Maybe we can chat with them.
If we hear anything back, I'm sure we'll get that information out to you. We are coming up to our time now, just so in respects to everyone's time, I think I will adjourn the meeting. If anyone has any questions or anything, or wants connections with anyone, please feel free to reach out, and we're more than willing to connect everyone to anyone else in this group. That's a big part of what we're doing. And if anyone has any comments on what's going on or wants more information, we're more than willing to share that as well. So please feel free to reach out at any time. Thank you, and have a great holiday weekend, and enjoy the weather. Hopefully you have some nice weather.
Yeah, thank you.